Limit definition of derivative involving conjugate. I have a function f of x equals to 1 over square root of x. I want to find f prime of x using limit definition. So f prime of x is using one function to describe the slope of the given function at any x value. But I said at any x value, right? That x value must be within the domain of the given function. So for example, this is 1 over square root of x. So you cannot have a 0 in the denominator, and the square root of negative is not going to work. So I said any x value in this function, the domain of the given function must be x greater than 0. So no 0 in the x, and then no negative in x. So x must be positive, which is x must be greater than 0. So for the limit definition, I always start with the limit definition, and then I plug in x plus h to the function, and then this is limit as h goes to 0, 1 divided by square root of x plus h, and then minus the function itself, and then divided by h. So since this is a complex fraction, I always pull the h out first. Limit as h goes to 0, I always do this, so 1 over h, and then I do the numerator inside the square bracket. So the numerator clearly requires a common denominator, right? So common denominator, I will just multiply two square root term, fraction bar, square root x plus h, multiply the square root of x. So the top, this is the square root of x, and then minus the square root of x plus h. So this one requires a conjugate for the numerator. The conjugate is the opposite side. So since that is a minus, I will multiply this by x plus, and then this is x plus h, and then the denominator, same thing, x plus h. All right. What is the next step? The next step is you have to multiply these two factors. Okay, what is that equal to? You have limit as h goes to 0, 1 divided by h square bracket. So you multiply the top, x times x, the square root is gone, and then you have a plus, you have a minus, right? So this one gives you a plus, right? And then you get a minus immediately. So they got cancelled. Just like a minus b times a plus b. The plus minus got cancelled. And then the two square root, you have a minus, right? Minus x plus h. And then divided by the numerator, the denominator, just put them right next to each other like this. Square root x plus h times root x, and then you multiply the green term, x, and then plus, maybe I can do this for you. I can match up the color for you. So square root of x plus root x plus h. Okay, what do you get on top? So the top, that is just equals to, so this is just equals to h, right? The top is just equals to h, and that h, get rid of this h. So you only have I was doing it too fast. X minus h. So that is equals to negative h, right? The top is equals to negative h. And then the bottom, this is an h. So this, get rid of the h, you have a negative 1 on top. Okay. Limit as h goes to 0. So now you have a negative 1 on top. And then what about the bottom? The bottom is just that piece. You have a square root x plus h times square root of x, and then multiply the green term, the green conjugate. So once h goes to 0, we don't need to worry about plugging in 0 because the biggest enemy is now gone. Okay, so once you plug in h equals to 0, you have a negative 1 on top, and then you have a root x times a root x, and then root x plus root x, right? Root x plus root x, and then what do you have? You have a x negative 1, and then you have a x multiply 2 times square root of x, and then you have a negative 1 divided by first degree plus a half degree, so that is 2 x to the 3 over 2. Or you can write negative 1, 2. You can do a square root first and then x to the third like that. Either one is fine, but I prefer this. What does that mean? That tells me y equals to negative 1 y prime or f prime of x equals to negative 1 divided by 2x raised to the 3 over 2. What is this? This is one function to describe the slope of the given function at any x value. The x value must be within the domain of the given function. So this is the slope of the given function at any x value. And then I have to specify that x must be greater than 0 because look at the given function. If you plug in a 0, bad. Plug in negative, the square root of negative is undefined, so therefore x must be positive. Alright, so what is next? The next is the blue problem. Find the tangent line at x equals to 4. So find the tangent line at x equals to 4. So let's box this answer first. And then I will find the tangent line for you. Okay, match the color. So when x is equals to 4, I need to find a point. Should I ask the f of x or f prime of x? You are looking for a point on the curve. Again, a point on the curve. The position. You are asking the f of x to do the job for you. So f of 4, 1 divided by root 4. So that is 1 over 2. So there is a point on the curve when x is equals to 4. Y is equals to 1 over 2. And then this is a point on the curve. And then the slope, you are asking f prime of x to do the slope for you. So that is negative 1 and then 2. You have 4 multiply 4, 3 over 2. So you can take the square root first. The square root of 4 is equals to 2. And then you have 2 to the third power is 8. 8 times 2 is 16. You have a negative 1 divided by 16. That is the slope. So now you have a point, you have a slope. You can use this point slope form, y minus y1 equals to slope times x minus x1. And then plug in, you have y minus 1/2 equals to negative 1 over 16, x minus 4, y minus 1/2 equals to negative 1 over 16x plus 4 over 16, so that is 1 over 4. And then you add a half to it, so that is y equals to negative 1 over 16x plus 1 over 4. The 1/2 is 2 over 4, so you have a 3 over 4. So let me make this simple, just write 3 over 4. What is this? This is equation of the tangent line. So equation of the tangent line to the given function f at a specific point at 4, 1/2. So what is the graph look like? The graph looks like this. You have your x-axis and then your y-axis. And then as x getting closer and closer to 0 from the right, the function goes all the way up. So basically the function looks like this. The function looks like this. And then you have 4, negative 1/2. The point is right over here. The 4, 1/2. And then what I'm asking is, this is a f of x equals to 1 over square root of x. I am asking you to do this. Find me the slope of the curve at that point when x is equals to 4. And then you found that the slope is equals to negative 1 over 16. And then you have a tangent line. The tangent line looks like this. So at this point you have a tangent line touching that point. And then the tangent line is y equals to negative 1 over 16x plus 3 over 4. The slope is equals to negative 1 over 16. Since the line and the curve, they are touching each other at that point. So negative 1 over 16 is the slope of the straight line and the slope of the curve. So now, at this point, if you watch the previous video, we have used the limit definition of derivative to do many derivatives. I want to give you a conclusion. So the conclusion is, there is a power rule. So there is a power rule for derivative. That is, f of x that is equals to x raised to some power f prime of x. The shortcut to do this without any limit is you bring the power down, and then you have x raised to the power minus 1, just like carry something down. In a library, okay, you raise your hand, you reach to the top of the shelf, you grab one book and then bring it down. Think about it like this. You grab the power, bring it down to the front, and then you take the power minus 1. So let's do some quick examples. So we have f of x equals to x squared, and then f prime of x, you bring the 2 down, and then you take the 2 minus 1. That is equals to 2x. If you use the limit definition, you will reach to the same answer. For f of x equals to x to the third, f prime of x, you bring the 3 down, and then x raised to the 3 minus 1, that is 3x squared. And then you have f of x equals to x to the 10th power, f prime of x, you bring the 10 down, and then x raised to the 10 minus 1, then that is 10x to the 9. So that will save you like 10 or 15 minutes to do the limit. Because if you have x to the 10, right? So let's say you want to do the f of x plus h, then this will be at x plus h raised to the 10th power. Then you have to use your Pascal triangle to expand this. You don't want to do this, right? What if that is a 50 power? X plus h raised to the 50. Do you want to expand that? No, I don't want to. Using the shortcut, you can get to the derivative right away. That works fine for this problem too. So we have f of x equals to 1 over square root of x. That is x raised to negative 1/2. F prime of that. So you bring the negative 1/2 down to the front, and then x raised to negative 1/2 minus 1. So you have negative 1/2 x to the negative 3 over 2, which is what I did, what we just did. What if there is a coefficient in front of the function, like f of x equals to 20 times x raised to the 8th power? Same thing. You bring it down, but in the meantime, you ignore the 20. So bring the a down, and then x8 minus 1. So you have a 160 x raised to the 7th power. So this is called the shortcut to do differentiation. Okay, the shortcut to do derivative. But let me clarify this. In this lesson, you study the limit definition. So when you do your works, you are required to use the limit definition. You have to learn this. You are required to go through this crazy algebra to reach to f prime of x. But once you get to the shortcut lesson, you will just follow the shortcut from now on. So every calculus student needs to learn limit definition. So when you do your homework for this section, don't be lazy, go through the limit. All right, so that's the end for this lesson. If you think this is helpful, give me a like, share, and subscribe, and I will catch you all in the next one. Signing out.